Hello everyone, so today we're going to talk about the Bayes theorem, which is a very important and very famous theorem in probability to use, and it is used very frequently, and I've already actually written down the theorem right here. So now for a moment, don't get too stressed about this. We will see how to apply it, and you will very easily understand this theorem. It's really something very easy, and if you do it many times, it will be obvious to you. Don't worry. Okay, so let's look at this exercise. An incipient form of cancer occurs in 3 out of 1,000 people. A screening test has been developed to provide early detection, but the test is not perfect. Among healthy patients, the test turns out positive in 5% of cases, false alarm. And among patients with incipient cancer, the test doesn't find it in 2% of cases, so a missed alarm. Suppose that everyone with a positive test is hospitalized for surgery. What proportion of people with a positive test actually have cancer? So the first thing we have to do in order to apply the Bayes theorem is we have to assign two letters according to the two variables of our exercise. So let's define letter C as having cancer, and let's assign P to having a positive test. But we also have to assign numbers to the inverse of these values. So C means not having cancer. It's the contrary, the inverse, not having cancer, and PC, not having a positive test or having a negative test, however you want it. Not having a positive test. Now we have to transform this this exercise and all the information we have here into probabilities. Okay, so an incipient form of cancer occurs in 3 out of 1,000 people. So that is very simple, just the probability of having cancer, probability of C, is 3 out of 1,000. Let's also write down the opposite. If the probability of having cancer is 3 in 1,000, then obviously the probability of not having cancer is 997 out of 1,000. Okay, screening test has been developed to provide early detection, but the test is not perfect. Among healthy patients, the test turns out positive in 5% of cases. So now we have probabilities that depend on each other. In that case, what we will write is this. Probability of turns out positive Let me explain this. When we write a probability like this, let's see, A, B. The second probability is something that actually happens. So it's as if we were calculating probability of A with a given B. So when we calculate this, we know that B actually happens. And based on that, we calculate what the probability of A is. And so here it is the same, because this is among healthy patients. So what our given is that those people do not have cancer. So this is our given. Sorry, I've written CC. This is our given. We know that those people don't have cancer, but the test turns out positive. It still is positive in 5% of cases. Let's also write the opposite. If it turns out positive in 5% of cases, well, it will be negative in 95% of cases, right? Okay. Now, among patients with incipient cancer, the test doesn't find it in 2% of cases. So now, among patients with incipient cancer, our given is that those people actually have cancer. The test does not find it, so the test turns out not positive in 2% of cases. And let's also take into consideration the opposite of this. That means that it will be positive if people actually are sick in 98/100. And now is when the Bayes theorem comes in. Because what is our question? What is the question we want to answer? What proportion of people with a positive test actually have cancer? So our question, what we want to find out is P, with the given that those people are positive. This is our given because it says what proportion of people with a positive test actually have cancer. So we want to know what is the probability with given positive test that those people actually have cancer. And now this is where the Bayes theorem comes in. So now just instead of using H and E, we will use C and P. Okay, so let's once again write it. This is what we want to find out. And now let's just apply this. It's the same as this times probability of C over, once again the same, plus P C times, and that is quite literally it. Now we just have to put in the stuff that we found out here. Okay, so we have 98/100 times probability of having cancer 3000, all of that divided by, once again the same, plus probability here, so 5/100 times probability of not having cancer 997/1000. And what do we get? Let's just take our calculating machine and we simply calculate this. And this is our result. We get 0.05569, or let's just say 5.57%. That's it. That's how you apply the Bayes theorem in an exercise like this. So what you have to do is you have to define two variables with two different letters, and also always take into consideration the opposite of those letters. And then you just apply this formula, which is the Bayes theorem, and you find out, in this case, what proportion of people with a positive test actually have cancer. So what is the practical way to consider what we just found out? What does this actually mean? This means that when, let's say you go and take a test, a cancer test, and it turns out positive, that means that even if it turns out positive, there is only 5.57% chance that you actually have cancer. So there you go. That is how you use the Bayes theorem. I hope you liked this video. If you have any question, just ask it in the comments and I will be happy to answer it. And please subscribe. Have a good day.